KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, we are discussing three-dimensional geometry. Okay, in three-dimensional geometry we are discussing planes concept. Already last class we discussed one form of equation of plane, that is in normal form. Okay, and we discussed example 13 and 14. Okay, we'll continue from there. Next question, find equation of plane, find the distance of the plane 2x minus 3y plus 4z minus 6 is equal to 0 from origin. Okay, we have to find distance of this plane from origin. Okay, to find out the distance of the plane from origin, okay, when it is given ax plus by plus cz is equal to d form. Okay, now here 2x minus 3y plus 4z is equal to 6. Now in this plane equation 2 minus 3 and 4 are direction ratios of normal to the plane. 2 minus 3 and 4 are direction ratios of normal to the plane. Okay, in plane equation ax plus by plus cz is equal to d, ABC are direction ratios of normal to the plane. So what we'll do is we'll write this given plane equation in Lx plus my plus nz is equal to d form. Okay, now means LMN are what? LMN are direction cosines of normal to the plane. So first of all we'll write direction cosines of normal to the plane. What are the direction ratios? 2, minus 3 and 4 are direction ratios of normal to the plane. Now when direction ratios, if ABC are direction ratios, then direction cosines are a upon square root of a square plus b square plus c square, b upon square root of a square plus b square plus c square, and c upon square root of a square plus b square plus c square. Okay, now using this, now as 2, minus 3, 4 are direction ratios, then corresponding direction cosines are 2 upon square root of 2 square plus minus 3 square plus 4 square, minus 3 upon square root of 2 square plus minus 3 square plus 4 square, and 4 upon square root of 2 square plus minus 3 square plus 4 square. Okay, so nothing but direction cosines are 2 upon root 29, minus 3 upon root 29, 4 upon root 29. Now these are direction cosines. What are the direction ratios? 2, minus 3, 4, these are direction ratios. Corresponding direction cosines are 2 upon root 29, minus 3 upon root 29 and 4 upon root 29. So what we'll do is, for this given plane equation, what is the given plane equation? 2x minus 3y plus 4z is equal to 6. Okay, so both sides divide with root 29, divide by root 29. Okay, dividing the equation 2x minus 3y plus 4z minus 6 equal to 0 throughout by root 29. What we get? We get it as 2 upon root 29x minus 3 upon root 29y plus 4 upon root 29z is equal to 6 upon root 29. Now if you observe, this is of the form, this plane equation is of the form Lx plus my plus nz is equal to d, where L, M, N are direction cosines of normal to the plane, and D is distance from origin to the plane. So distance from origin to the plane is how much here? 6 upon root 29. 6 upon root 29. Okay. So this is the form. This is of the form Lx plus My plus Nz is equal to D, where D is the distance from origin to the plane. So the distance from origin to the plane is how much? 6 upon square root of 29. 6 upon square root of 29. Okay. Here question is to find distance of the plane from origin. So first of all, write given plane equation Ax plus By plus Cz is equal to D1. You write in the form of Lx plus My plus Nz is equal to D. Simply corresponding to direction ratios, find direction cosines. Okay. So here what we got here, direction cosines 2 upon root 29 minus 3 upon root 29, 4 upon root 29. Nothing but divide throughout by root 29. We get this plane equation Lx plus My plus Nz is equal to D form. Okay, where Lmn are 2 upon root 29 minus 3 upon root 29 and 4 upon root 29, and D is how much? 6 upon root 29. That D is nothing but distance from origin to the plane. Okay, next question. Next question. Find the coordinates of foot of perpendicular from origin to the plane 2x minus 3y plus 4z is equal to 6. Previous question, this question plane equation is same. Here question is find the coordinates of foot of perpendicular from origin to the plane. Means from origin foot of perpendicular is drawn. Okay, from origin a line is drawn perpendicular to this plane. Okay, and this line intersect the plane at point P x1 y1 z1. P x1 y1 z1. We have to find the coordinates of P x1 y1 z1. Okay, we have to find coordinates of P x1 y1 z1. Okay, that is what it is written here. Let the coordinates of foot of perpendicular P from origin to the plane is x1 y1 z1. Now we have to find x1 y1 z1. Okay, now if you observe here, P is a point x1 y1 z1, O is origin 0 0 0. Okay, now what we know, point minus point always gives direction ratios. Okay, direction ratios of OP bar are what we get, direction ratios of OP bar are x1 minus 0, y1 minus 0 and z1 minus 0, nothing but x1 y1 z1. Okay, so direction ratios of OP bar are x1 y1 z1. This is one thing. What is the plane equation given? Given plane equation is 2x minus 3y plus 4z is equal to 6. Here 2 minus 3, 4 are direction ratios of normal to the plane. Direction ratios of normal to the plane. Okay. Now I will write this plane equation in equation of plane in normal form. Means I will write this plane equation as Lx plus My plus Nz is equal to D form. Okay, now using previous problem, now what is vector form, equation of plane in normal form, Lx plus My plus Nz is equal to D. So what we have here, 2 upon root 29x minus 3 upon root 29y plus 4 upon root 29z is equal to 6 upon root 29. Okay, so writing the plane equation of plane 2x minus 3y plus 4z is equal to 6 in normal form, we have, what we have, this is the plane equation normal form. In normal form, 2 upon root 29x minus 3 upon root 29y plus 4 upon root 29z is equal to 6 upon root 29. But this plane equation is of the form Lx plus My plus Nz is equal to D. So what are the direction cosines? Direction cosines are 2 upon root 29 minus 3 upon root 29 and 4 upon root 29. Okay, so 2 upon root 29 minus 3 upon root 29 and 4 upon root 29 are direction cosines of OP bar. Okay, these are direction cosines of OP bar. What are direction ratios of OP bar? Direction ratios of OP bar are x1 y1 z1, x1 y1 z1. Now direction cosines of OP bar are 2 upon root 29 minus 3 upon root 29, 4 upon root 29. Okay, now we have direction ratios of OP bar and direction cosines of OP bar. What we know? Direction cosines and direction ratios are proportional. Direction cosines and direction ratios are proportional. Okay, suppose x1, y1, z1 are direction ratios and ABC are direction cosines, or else x1, y1, z1 are direction ratios and L, M, N are direction cosines, then what we can write? x1 by L is equal to y1 by M is equal to z1 by N is equal to some constant. Okay, where constant is proportionality constant. Okay, since direction cosines and direction ratios are proportional, so what we have, x1 by 2 upon root 29 is equal to y1 by minus 3 upon root 29 is equal to z1 by 4 upon root 29 is equal to k. Okay, cause direction cosines and direction ratios are proportional to one another, what we have as x1, y1, z1 are direction ratios and 2 upon root 29 minus 3 upon root 29 and 4 upon root 29 are direction cosines, then what we have, x1 upon 2 upon root 29 is equal to y1 upon minus 3 upon root 29 is equal to z1 upon 4 upon root 29 is equal to k, where k is proportionality constant, where k is proportionality constant. So from here what we can write by equating these two, x1 is equal to how much? 2 upon root 29k. Okay, x1 is equal to 2k upon root 29. y1 is equal to what? y1 is equal to minus 3k upon root 29 and z1 is equal to 4k upon root 29. So x1, y1, z1. Okay, so what is the foot of perpendicular from origin to the plane? P x1, y1, z1, nothing but P 2k upon root 29 minus 3k upon root 29 and 4k upon root 29. Okay, to find out this point we have to find what is k. What is k? Now what is P? P is a point on the plane. P is a point on the plane. So P x1, y1, z1 satisfies plane equation 1. Okay, P x1, y1, z1 satisfies this plane equation. No? Okay, so in place of x, y, z, substitute x1, y1, z1. So what we get from 1? 2x1 upon root 29 minus 3y1 upon root 29 plus 4z1 upon root 29 is equal to 6 upon root 29. Okay, but what is x1, y1, z1? x1, y1, z1 are 2k upon root 29 minus 3k upon root 29 and 4k upon root 29. Now substituting in place of x1, y1, z1 these values, so what we get? 2 upon root 29 into x1 is 2k upon root 29 minus 3 upon root 29 into what is y1? Minus 3k upon root 29 minus 3k upon root 29 plus 4 upon root 29 into z1. z1 is 4k upon root 29 is equal to right hand side 6 upon root 29. So here if you observe 4 upon 29, 2 into 2, 4 upon root 29 into root 29, 29. 4 upon root 29, 4 upon 29. Now minus of minus plus 9 upon 29 k 16k upon 29. So LCM is 29. Okay, numerator is also 29k. So 29k upon 29 is nothing but k. K is equal to how much? K is equal to 6 upon square root of 29. Okay, now substituting 6 upon substituting k value 6 upon root 29 here. So what we get? Foot of the perpendicular x1, y1, z1 is equal to 2 into root 29 into k. K value is how much? 6 upon root 29. So 6 into 2, 12 upon 29, comma, minus 3 by root 29 into 6 by root 29, denominator 29, numerator minus 18. Minus 18 upon 29. Similarly, this is 24 upon 29. So foot of the perpendicular is 12 upon 29 minus 18 upon 29 and 24 upon 29. Okay, now here what we have to find? We have to find coordinates of foot of perpendicular drawn from origin to the plane. Okay, now P be the point where foot of perpendicular intersect the plane. Okay, so let it point is P x1, y1, z1. So P is a point on the plane, so it satisfies this plane equation. So what we can write? 2x1 minus 3y1 plus 4z1 is equal to 6. That is one thing. Okay, now this is a plane equation. 2x minus 3y plus 4z is equal to 6. Okay, here 2 minus 3 4 are direction ratios. Corresponding direction cosines are 2 upon root 29 minus 3 upon root 29, 4 upon root 29. Okay, if you write in normal form means Lx plus My plus Nz is equal to D form. So what we have from previous problem, 2 upon root 29x minus 3 upon root 29y is equal to 4 upon root 29z is equal to 6 upon root 29. So here direction cosines of OP bar are what? 3 upon root 29 minus 2 upon root 29 comma minus 3 upon root 29 and 4 upon root 29. These are direction cosines. Okay, what we know, direction ratios and direction cosines are proportional to one another. So x1 upon this part, y1 upon this value, z1 upon this value is equal to k, where k is some proportionality constant. So x1, y1, z1 we have like this. Okay, so x1 is equal to 2k upon root 29, y1 is equal to minus 3k upon root 29 and z1 is equal to 4k upon root 29. Okay, now as x1, y1, z1 is a point on the plane, x1, y1, z1 satisfies the plane equation. Okay, so in place of x, y, z, if you substitute x1, y1, z1, we get this one. Okay, but x1 is this value, y1 is this value and z1 is this value. By substituting in place of x1, y1, z1 these values, we got k value is 6 upon root 29. Substituting k value 6 upon root 29 here, we got x1, y1, z1 as 12 upon 29 minus 18 upon 29 and 24 upon 29. Okay, but one note, that is when you know distance from origin to the plane, and direction cosines of normal to the plane, through origin, then foot of the perpendicular is LD, MD, ND. Okay, I will repeat once again. If D is the distance from origin to the plane and L, M and R direction cosines of normal to the plane through origin, then foot of perpendicular is LD, MD, ND. That is what we did here. What is LM and R? 2 upon root 29 minus 3 upon root 29, 4 upon root 29. These are LMN. What is D? D is 6 upon root 29. So LD, this two product is how much? 12 upon 29. MD, how much? Minus 18 upon 29. ND, how much? 24 upon 29. Okay. So if D is a distance from origin to the plane and L, M and R direction cosines of normal to the plane through origin, then the foot of perpendicular is MD and ND. Okay. Okay, my next method, equation of plane when a perpendicular perpendicular to a given vector and passing through a given point. Okay, means a point on the plane is given and normal vector to the plane is given. Okay, equation of plane perpendicular to a given vector means normal to the plane is given and passing through point given, then equation of plane. Okay, now suppose a plane is passing through the point A with the position vector A bar. Okay, so A is a point x1, y1, z1. Okay, so OA bar is A bar, and N bar is normal to the plane. Okay, N bar is normal to the plane means N bar is perpendicular to plane. So what we can do? Well, we can choose some arbitrary point in the plane. Okay, let it be P. Okay, corresponding position vector is R bar. Okay, now what we have here? OA bar is A bar, OP bar is R bar. By triangle of vector addition, OA bar plus AP bar is equal to OP bar. So AP bar is equal to OP bar minus OA bar, nothing but AP bar is equal to R bar minus A bar. This is one thing. Now what we know, AP bar is a vector in the plane. Okay, AP bar is a vector in the plane and N bar is normal to the plane. Okay, so N bar is normal to the plane and AP bar is a vector in the plane. So what we know, AP bar and N bar are perpendicular to each other. AP bar and N bar are perpendicular to each other. Now because AP bar is a vector in the plane and N bar is normal to the plane. Okay, as normal is perpendicular to plane, okay, normal is perpendicular to every vector in the plane. So AP bar is a vector in the plane. So AP bar and N bar are perpendicular to each other. Okay. So as AP bar perpendicular to N bar, two vectors perpendicular to each other means the dot product is 0. So AP bar dot N bar is equal to 0. What is AP bar ma? R bar minus A bar. So R bar minus A bar dot product with N bar is equal to 0. But this is the required vector equation of plane. Passing through a point A with position vector A bar and N bar is normal to the plane, then equation of plane is R bar minus A bar dot product with N bar is equal to 0. Okay. This is vector form. Now corresponding Cartesian equation. Okay. Now here known point A as we'll consider as x1, y1, z1. So OA bar, A bar is equal to what we can write, x1 I cap plus y1 j cap plus z1 k cap. Okay. Some arbitrary point what we consider P. So arbitrary point means x, y, z. Okay. So its position vector R bar is equal to xi cap plus yj cap plus zk cap. Okay. And direction ratios of normal will consider as ABC. Okay. Let ABC be the direction ratios of normal. Okay. So what we can write, N bar is equal to AI cap plus BJ cap plus CK cap. Okay. Now we have A bar, R bar and N bar. Now substituting these in 1. So what we get, R bar minus A bar dot N bar is equal to 0. R bar minus A bar, what we get, R bar minus A bar is x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. Dot product with N bar is AI cap plus BJ cap plus CK cap is equal to 0. So if you take dot product, what we get, A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0. Okay. But this is a Cartesian equation of plane. When a plane is passing through point x1, y1, z1 and direction ratios of normal to the plane are ABC, equation of plane in Cartesian form is A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0. Okay. Next, we will discuss one problem on this model. Okay. Example 17. Find vector and Cartesian equation of plane which passes through the point 5, 2, minus 4 and perpendicular to the line with the direction ratios 2, 3, minus 1. Find vector and Cartesian equations of plane which passes through. Passing through point given, what it is, 5 to minus 4. Okay, plane is passing through the point 5 to minus 4. Okay, passing through point given. Okay, and perpendicular to the line with the direction ratios 2, 3, minus 1. Okay, my line is perpendicular to the plane with the direction ratios 2, 3, minus 1. So normal given and passing through point given. Okay. Now we have point 5 to minus 4 with position vector. What we can write, my position vector of this point is A bar is equal to 5y cap plus 2j cap minus 4k cap. Okay, we have position vector of the point 5 to minus 4 as A bar is equal to 5y cap plus 2j cap minus 4k cap. Okay, and normal vector N bar perpendicular to the plane is what? Okay, now what is given, line is perpendicular to the plane with the direction ratios 2, 3, minus 1. 2, 3, minus 1. So N bar is equal to what we get, N bar is equal to 2a cap plus 3j cap minus k cap. Okay, passing through point we have and normal vector we have. So vector equation of plane is what, R bar minus A bar dot product with N bar is equal to 0. R bar minus A bar dot product with N bar is equal to 0. So R bar minus A bar is what, 5y cap plus 2j cap minus 4k cap dot product with N bar is 2a cap plus 3j cap minus k cap is equal to 0. Okay, but this is vector equation of the plane. This is vector equation of the plane. Okay, now what is R bar? R bar is position vector of any arbitrary point on the plane. Okay, R bar is a position vector of any arbitrary point on the plane. Okay, let arbitrary point be p, x, y, z. So corresponding position vector what we can take, R bar is equal to xi cap plus yj cap plus zk cap. Okay, xi cap plus yj cap plus zk cap. So r bar, if you substitute here, so what we get, xi cap plus yj cap plus zk cap minus 5y cap minus 2j cap plus 4k cap, dot product with 2y cap plus 3j cap minus k cap is equal to 0. Okay, now further what we can write here, xi cap minus 5y cap. So what we can write, x minus 5y cap plus yj cap minus 2j cap, y minus 2j cap plus zk cap plus 4k cap, that we can write as z plus 4 k cap, dot product with 2y cap plus 3j cap minus k cap is equal to 0. We take dot product, what we get, 2 into x minus 5 plus 3 into y minus 2 plus minus 1 into z minus 4 is equal to 0. So what we get, 2x minus 10, 3y minus 6 minus z minus 4 equal to 0. Nothing but 2x plus 3y minus z minus 20 equal to 0. That is 2x plus 3y minus z is equal to 20. And this is the Cartesian equation of the plane. This is the Cartesian equation of the plane. Okay. Now we'll conclude up to here. We'll continue remaining problems in next class. Thank you.